Hello folks, hopefully be a pretty quick video for you today. Just want to update you on our E39 new replacement battery build project. So what we've got here for you is that was the original rear battery box that we had in the car that originally held some of those CALB grey cells that you see there. And we're currently doing capacity tests on the entire pack of those for you, for those of you that are battery nerdy. So I think this box held something like 25 or 28 cells. And we have our new BMW hybrid pack, the full 260 volts worth, fits within this box. So let's bring you over and get you a nice top-down view here with some of my expert camera work, of course. So we got our 6 modules by some kind of a weird miracle actually fitted perfectly within the box here. Now what we're doing today is we are adapting the box to mount these modules in there. And the reason we have to do some adaptation is twofold. The first is we need to be able to physically mount them in there, which is pretty simple because they've got these nice holes here, and we've got the original M6 bolts to hold them in there. Problem is, because these are hybrid modules, they're very power dense, so they're subject to temperature swings. When we draw a lot of current from them, they're going to warm up. When we charge them hard, they're going to warm up. So we have to give that heat someplace to go. Now in the original vehicle, that was done by means of actually quite a complicated system involving the aircon system and refrigerants and freons and whatever else. Now we're taking a slightly simpler approach here. What I've done is I've got myself a nice 10mm aluminium plate here. So it's 10 millimeters thick. And I've got this cut to size so that it's about 3 mil smaller than the box. So it should drop straight in there. Obviously then we can locate the holes, drill and tap and bolt our modules down to that. But we need to put this plate into the box. We need to have some way of securing it in there. Now what we're going to be doing is we are going to be having a go at some aluminium MIG welding. Now, as you'll see here, I've been doing a few practice welds and I'm starting to get the hang of it. It's it's kind of the same but subtly different to welding steel or stainless steel. Now this is my first go at it. So I'm not going to really make this a tutorial video on how to do aluminium MIG welding, but what I will say is that the one thing that I found out while I was researching this was, by far and away, the most important thing to do is to get a Teflon torch liner. Okay, so this is not like the normal torch liners that you see that kind of look like an old curtain wire. This is PTFE, and you want this for 2 reasons. Number one, it's not going to contaminate the wire as it goes through it. And the second one is the wire can go through it'll be a lot easier for the wire feeder to push the wire through it to the torch. So, alright, I'm not going to blather on too much. What we're going to do is we're going to get those modules out. I'm going to drop the plate in. We're going to brush around there, get rid of some of the crud from around the periphery where we're going to weld. Then I'm going to warm this up. I'm going to do some preheating And we'll come back when I'm going to throw a few beads in here and see what kind of a mess that I can make out of this. Stand by. So for those of you that think that this isn't going to sufficiently heatsink those cells, batteries, modules, we got a 10 kilowatt propane heater blasting into this thing for the last 15 minutes just to take the chill really out of this plate so that we can start welding it. So yeah, I think this is going to work out. Alright, let's go ahead and give this a shot. Chances are, because I'm on camera here now, this is going to all fail spectacularly for you guys to see. Definitely got the chill out of that plate, because the problem is the plate is 10 mil, but the box is made from 2 mil. So our chances of not tying into the plate go down dramatically if we take the chill out of it. So I'm going to try this corner. Wish me luck. Okay. Alright, take 3, or whichever it is. Yay! Certainly got it to tie in alright. So it's been a bit of a struggle, folks, but I think we got the machine dialed in to the point now that we're actually making good welds here, and we're not bird's nesting. So do a couple more, then we'll wrap it up. Of course, as soon as I said that, definitely tying in nicely. I don't think this plate's going to fall out. Just going to do probably just one more weld over here in this corner, and then we're going to call it done, as if I don't trip over something. Wow. One thing I have to say for this is that it is a very fast process. I mean, if I was TIG welding this now, it'd be, this would have been a much harder, or much slower process. Neater, but slower. Yeah, we're making some nice welds now, folks. Probably as well, we're starting to get more and more heat into the plate, which certainly doesn't hurt us. Oops, gotta go over my toes. There goes the plug again. So I think for someone that's, you know, never used this process before, literally only started today, I gotta say, folks, it's doing well. Now, remember folks, when you stare into the battery box stares into you. So, heatsink compound. We've our all holes drilled and tapped. I've cleaned down this plate as best as I can. As I say, the welds are functional. They're not going to appear in next month's issue of Meat Welding Monthly. Right, let's get some heatsink compound in here. Ooh, look at this. Well, I should be doing it more like this, really. The original heat sinks didn't have any of this on them, but I've decided, screw it, I'm going to put some heatsink compound in here. At the very least, it'll make the batteries slide around easier. Well, that's that one finished. Right, side 2. Alrighty folks, so just a very quick look here at the wiring for this BMS harness. What I've done is I've stripped out all these plugs and bits here that we don't need. I was going to go and strip down the whole wiring loom, but I kind of figured, yeah, there's no point doing that, so I've just cut off, I guess, the plugs and stuff that we're not using. And over here at this end then, got a 120 ohm resistor in here to terminate the can. Can is on the yellow red, can high, the yellow brown, can low. We've got a blue wire here, which is, I guess, some kind of a fault signal. We're bringing the other end of the can out. We've got a ground just on the brown and the black here, and a 5 volt on the red. And I'm just bringing all those out just on a little bit of screen cable here. So I'm going to go ahead and just tape up all this, and then we got a plug here to on the end of the Simp BMS. We can throw all this harness then pretty much into the box, and we should be able to talk to the modules. Now at this point we can't talk to them per se, we can listen to them, but we don't know what they're saying as yet. Alrighty, so we have our battery pretty much done, folks. We got our high voltage harness in, we've got our BMS harness in. I got our BMS harness coming out here, just on a bit of this cable. Got my ESP32 CAN Dewey thing on there. Got a little power supply just providing 5 volts. And we've got all our CAN messages from our modules coming out through that. So basically we're at a point now that pretty much tested this out. It's ready to go in the car. I was able to reuse all the original interconnect wires, so that worked out nice. Some of these here with this custom plug on them, I was able to cut them off, and it turned out that, you know, what they did in here was quite simple. They just used 2 16mm cables, so I could just crimp a 35 square on there, and that gives me a normal kind of a ring terminal there to connect to the various contactors and bits in the car. Our box will go on there where it was before, and bring our cables out into that. And yeah, that'll be our, I guess that's our high voltage battery. This is full 360 volts. Nominally I think 9.5 kilowatt hours. And as you've seen there now, we've got everything's bolted in, got some passive cooling going on. If we find we need more, well, we can always get some airflow going in there with something like a Prius battery blower, something like that. I'm not gonna get all tied up in knots trying to do liquid cooling on this thing. We'll keep it simple for now. Okay, so there's our battery in. I'm pretty much at the minute just tidying up the wiring in. I suppose this would have been the rear high voltage junction box. So making some changes in there, obviously, because the way that we're connecting into this battery is slightly different from the way that we had the calb cells, because they were quite spread out through every nook and cranny, whereas this battery is housed within the one container. So as you would have seen, let me get you guys in there a little bit closer if we can. So basically in here now, what we've got is we've got the rear contactor, which we've got our most negative terminal here attached to that, and we've just got a terminal, a kind of a bolt post here for the most positive. So between here and here we have the full pack voltage of 360 odd volts nominally. So what I want to do here now is I want to basically tidy up all of this chop block and get rid of this and solder and heat shrink up all these wires. Put a piece of conduit, a little bit of that orange conduit over this just to tidy that up. There's a couple of routings here of wire that I want to change. I decided to leave the EV display in. I mean, it's already there and it's worked in the car for 8 years now, so why not leave it there. Made one little modification. It's just to put these are little solar fuses. They're rated at 1000 volts DC, 500 milliamps, so that just comes off the positive and negative here, so it just lets us monitor the pack even when the car is fully shut down, which is quite handy. We will have a VCU up front. I'll make it out of one of the Lexus ones, but this will give us a little bit of a secondary option for battery monitoring. Obviously for full battery monitoring we'll have our BMS can here, so we'll be working on getting that talking as we described previously. So everything's in at the minute, as I say, as you would have seen there. Everything is, all the pack interconnects are in. I've got everything except the negative and the positive plugged into the battery there. I won't be doing that until we're ready to put power on. But it's all bolted in, it all went in quite handy, so just got a bit of clean up to do in here now, and we should be good to go. And up the front here we're in pretty good shape also. Tesla charger is in, connected up. Got one of my new V5 boards in this, so I know some people have reported the Wi-Fi on that doesn't work and a few things, so now that I've got one of these in a car with one of the V5 boards in it, I'll be able to have a look at that. Our Gen 3 Prius inverter is in, ready to go. Our front, I guess our main high voltage junction box is in. Got the ISA shunt and all the other bits that we need in there. I've just got to finalize some signal wiring and get this AC wiring from the charge port extended in here. But everything is pretty much ready to go here. So what we'll be doing is, for kind of pre-charge and high voltage control, we'll be using our ISA shunt in conjunction with, let's say, one of the Lexus GS450H VCUs. We'll just have a little bit of custom software on there, so it'll basically handle pre-charge and controlling the inverter and the charger, and it'll have the advantage too that I can hook everything up to CAN. I can have CAN from the inverter, I can have CAN from the shunt, and I can have CAN then from the BMS in the back, and we'll get everything to talk away merrily, hopefully. So we're making good progress on the car here. It's really, you know, anytime you make a mistake with something, as I did with that previous drivetrain, it's always, you know, you got to go back at it and do it again and again and again. It's a pain, but you know, you kind of learn. From your mistakes. And I know some of you have been asking in various comments and that what I'm doing with these calb cells, but basically what we're doing with them is we are capacity testing them all. We're charging them up full, we're discharging them and then charging them back up, doing full capacity tests on them. Thanks to this super duper power supply here, we can pump up to 130 amps into them. So we're going to be testing them, and then they are going to be repurposed on my, I'll show you this here, on my solar power system. So I got a inverter charger and currently a fairly small battery there on that. So once we get these guys filtered out, I guess, we will be reusing them, kind of the old second life of batteries story. It's going to be happening here in real life also. Some of you have been asking in terms of the E39 what I expect the range to be with that pack. No idea, but I will report on that when we have some factual figures for you. And I am going to be on the hunt then for a second one of those packs that we can install here underneath, because there's loads of space there. But that's kind of something I'll do on a vehicle lift or something like that from underneath the car. So that's about it, folks. Bit of an E39, a little bit of a I guess just a few snippets of what's been going on. There's an awful lot of projects happening right now, but I'm just trying to get this car moving pretty soon. So there we are, folks. I hope that's made sense anyway. As I say, give you a little bit of a few snippets of what's been going on with the E39. Next time we come back to the vehicle, we'll have the motor spinning and hopefully be able to drive. This will also be the first time, to the best of my knowledge, well, it's certainly the first time that I've used a Prius Gen 3 inverter to do anything but spin a motor on a bench. So we'll be able to do some reporting on that for you. Still got to get back to the Model 3 drive unit to get that spinning, but that's for another video. Obviously here in this case we have the choice of running with, at the minute it's set up to run from just the MG2 power stage. We have the choice of paralleling them. If we find that we need more current, we can bring MG1 in to assist. So alright, I'm going to wrap it up there, and I will catch you guys in the next semi-exciting episode. Don't forget to dislike, unshare, unsubscribe as quick as you can. And do check the links in the description. Usual suspects in there, particularly around the Open Inverter Forum and GitHub for all the design related stuff, PayPal and Patreon should you wish to financially support me in this crazy quest that I seem to find myself on. So I'll leave it there, and until then, happy BMW hybrid battery BMS can hacking.